Powered Parachute 7-3 Takeoffs and Departure Climbs. Understanding the runway surface and gradient is key to mastering takeoff performance. Runway conditions can greatly impact your takeoff, especially when you're dealing with diverse surfaces. Whether it's a grassy field or a smooth runway, your tire's ability to roll smoothly is crucial. Soft or uneven surfaces can lead to increased ground roll, and obstacles like mud or standing water can hamper your acceleration. The runway slope, expressed as a percentage, affects takeoff. A positive gradient means the runway rises, hindering acceleration, while a negative gradient aids acceleration, resulting in a shorter takeoff. Always check the airport or facility directory for runway slope information. Moving on to takeoff performance, it's all about accelerated motion. 3 key factors define it: takeoff speed, rate of acceleration during the roll, and takeoff roll distance, which depends on both speed and acceleration. Minimum takeoff distance is vital, dictating the runway requirements for inflation, lock procedure, lift-off, and climb. Your powerplant thrust is critical here. Maximize it after wing inflation for an efficient takeoff. Remember, a smooth, gradual throttle is crucial to avoid porpoising. Drag comes into play as soon as you move forward, and the wing's drag decreases as it positions over the cart. Many variables affect takeoff performance, but getting the wing overhead and centered quickly is paramount. Headwinds play a crucial role. Even a slight headwind significantly reduces takeoff distances. For instance, a 10% headwind can cut takeoff distance by 19%. Gross weight also matters. An increase affects lift-off speed, acceleration, and retarding forces. Even a 33% increase in takeoff weight can lead to a 76% increase in takeoff distance. In conclusion, understanding runway conditions, gradients, and the interplay of factors affecting takeoff performance is vital. Stay mindful of these elements, especially when it comes to headwinds and changes in gross weight, to ensure a smooth and efficient takeoff. Let's dive into the intricacies of powered parachute takeoffs. As you embark on this aerial journey, the takeoff process holds a crucial role in ensuring a safe and smooth flight. Picture the runway ahead and imagine the interaction between your aircraft and the elements. As you prepare for takeoff, your primary objectives are twofold: pressurize and elevate the wing overhead, ensuring proper inflation, and generate the necessary airflow for lift. It's a delicate balance, akin to choreographing a performance between your powered parachute and the forces at play. Before the wheels start to roll, perform a final check of your surroundings. Confirm the cart's alignment, and ensure no obstacles stand in your way. Glance over your shoulder, observing the graceful inflation of the canopy. Now, with a steady hand, smoothly advance the throttle to about half to 2/3 of takeoff power. Avoid abrupt power surges, especially with high horsepower engines, as this can yank the wing forward harshly, potentially causing damage. As the cart begins to roll, both feet should firmly rest on the steering bars, ready to guide the parachute's movements. Watch as the wing starts its ascent, acting like a parachute with substantial drag initially. The cart moves forward slowly until the wing reaches a critical 50 degrees angle to the ground. At this juncture, the drag significantly decreases as the parachute transforms into a wing, propelling the cart forward rapidly. Here comes a crucial moment. As the cart gains speed, you must judiciously reduce the engine thrust. Too much reduction may cause premature liftoff, risking damage to the wing. Conversely, inadequate reduction may lead to excessive acceleration, potentially causing a locked-out wing in the prop wash. Keep a keen eye on the wing's inflation behind the cart. If one side inflates faster than the other, a gentle steering correction ensures balance. At this pivotal point, most of the powered parachute's weight rests on the wheels, transitioning from ground to wing. Divide your attention between cart direction and wing status. Perform a rolling pre-flight as the wing ascends overhead. A quick inspection for full inflation, free lines, and potential issues like line overs or pressure knots. Line overs are unmistakable deformities, signaling an immediate shutdown and a reset. End cells not inflating? Patience is key. Sometimes, weighting or lightly pumping steering tubes can assist. Pressure knots, a trickier challenge, might require a keen eye on wing deformations. Attempting takeoff with a pressure knot risks a sharp turn, hard to correct without almost stalling the wing. The process continues, and now you're at the mercy of wing oscillations. Light oscillations are acceptable, but excessive ones can lead to undesirable effects like airframe rolls. Prevention is better than correction, but if oscillations occur, steer opposite to the drifting side, managing the wing straight. Verification is critical. Ensure the wing and lines are fully inflated, centered above the cart, and free of tangles. The lock, as it means lines free, cells open, wing centered, serves as your go-to checklist. With a fully pressurized wing, centered above, and lines untangled, smoothly increase the throttle to takeoff thrust. Feel the increased thrust propelling the powered parachute forward, and gradually raise the throttle until the airflow over the wing generates enough lift to lift the powered parachute airborne.